So we're going to talk real quick about end behavior. End behavior is determined by the highest power of x and helps us graph more complicated polynomials. So if I have, say, something that, let's move up, I think I can fit my example in here. F of x equals negative 5x of 4 minus 6x squared plus 2, then I can say, well, my highest power is this fourth. That overrules all my other power, because raising something to fourth is so large, it's so much larger than something squared, that the squared doesn't even really affect it anymore. So I'm always just looking at my highest power. So I'm just going to say my end behavior of this is basically the same end behavior of a negative x to the 4. So I'm not really going to worry about the shifting. I'm not going to worry about is it stretching or shrinking. I'm just looking at end behavior. So a negative x to the 4, I kind of already know what that looks like. The x to the 4 is basically a parabola. It's just a little flatter. So a negative x to the 4 would be a negative parabola, meaning reflected over the x-axis. So end behavior is kind of saying, well, what happens at the ends of this graph? And it's going to help us graph some of these in a minute. So I'm going to say the end of this graph, as this thing goes further out to my left, meaning to my negative x's, so as x goes to negative infinity, then how does it go? It goes down. What do my y's do? So as it goes further out to my left, as x goes to negative infinity, my y's go to negative infinity. What happens on my other side? On my other side, as x goes to the right, as my graph goes to the right, so as x goes to positive infinity, don't really know if I need positive, but why not? Then my y continues going down. So my y is still going to negative infinity. Okay, so let's try one more, and then we'll see how this actually helps us graph. So say we have, I'll keep that up there. Say we have 4x cubed plus 3x squared plus 2x minus 1. My highest power is the cubed, and that's going to overrule every other power. So I'm going to say that this graph is going to be similar, or at least have the same end behavior as a regular x cubed graph. It's a positive x cubed. We don't care about stretching and shrinking. We don't care about moving. We're just trying to see what happens at the end of this graph. So it's the same-ish as an x cubed graph. So, x cubed graph, if I can draw it out again, it goes to the right and up, to the left and down. So if I look at this, as my x's are going to the negative, as I'm going to negative x's, so as x goes to negative infinity, then my y is going down. So my y is going to negative infinity. Okay, as my x is going to positive infinity, so as my x is going to the right, going to infinity, my y's are going up. So my y is going to infinity. So this is going to help us graph some of these in a few minutes.